All right, guys. So as mentioned before, we're wrapping up SQL week, databases week. We learned a lot about SQL. We had a great workshop on Tuesday led by Jack and Jake. Really understand the basics of creating a good database design and then working with the data to query whatever you want out of it. So we're going to go and have a good review today, make sure we understand the basics of querying a database, creating a schema, and kind of how all that ties together. But yeah, let's just kind of get started here. Before I kind of dive into what I want to go over, I just want to ask the audience, what are some things that you guys want to cover in the review today?
I would say joins. Like I'm not super I feel like I haven't done anything with joins this week.
Absolutely. Yeah, I'm going to try to sneak in a, do it yourself activity where I'm going to ask you to write a few queries and we'll see how you guys do and we'll work on it together if we have time for it. Okay, so joins are on the list.
All right, can I say like embedded select statements, especially if there's more than one?
Embedded select statements. Yeah, those get tricky. I think, yeah, we'll try to sneak those in. I will let you know for the assessment, you're not going to have to do any embedded select statements, but that is a little more advanced SQL. Just to cover again what's on the assessment, you're not going to need to use psychopg. Again, that was nice to know. Good example of how Python makes easy to kind of work with databases, but you won't have to worry about using psychopg or Python and psychopg with the assessment, just to highlight that. So we could review that, but want to dedicate time to the basics from earlier in the week. All right, so we have using joins, and then we have, I'm going to add in many-to-many relationships because I know that's something we want to cover a little more in depth. And then we have time, maybe embedded select statements. Those, again, get a little tricky, but we'll see if we could maybe try that. Anything else that you guys want to cover?
Hey, Ankur, is there any, like for the assessment, since it looks like we're going to be incorporating SQL and databases to some sort of web design, could we go over a little bit of like, I guess that's the API maybe between your like JavaScript and SQL queries?
Yeah, we'll talk about the assessment at the very end of the review. I'm glad
Okay.
you guys kind of have a heads up maybe of what it might cover. We'll talk about that. All right, cool. Thanks for the question. Oops, I muted myself. All right, let's just get into today's review. So for today's review, I thought it was better to just cover a concept or a scenario that we've talked about before rather than kind of introducing a whole new system. So I thought I feel like the school system hopefully we're comfortable with it and made this example maybe easier to digest. So I'm going to go over the school design again, where we have, again, students, we have courses, we have professors. I'm going to add in lockers. So instead of having an addresses table, I'm going to use lockers just to highlight maybe a one-to-one relationship that we might have. But yeah, so hopefully we're comfortable with the idea of a school, some unique entities where we talk about, again, professors, courses, students, and see how those come together to create our schema. So am I sharing my screen? Yes, hopefully. You guys can see my screen, right? Can I get a thumbs up?
Yes.
All right, thanks. Usually has a green bar around it. All right, so I'm just going to go through this page. I try to adding examples to make sure we had a lot of good coding examples, but going to kind of stick with this page and hopefully won't veer too much off of it. But happy to kind of go on tangents as needed. But let's kind of just get to our coding window because that's the best way to go about it. Let's go. I guess I'll save queries towards the end. I'm going to talk about schema design because I think that's probably the more harder portion here. So let's create a new file called schema.sql. And then we need to design our schema. Now, as we talked about, this is a process. And usually the 3 steps I outline are think about your design, create your entities, and then the relationships. So I like going to my visual tool here. So I'm going to go to schema or quickdatabasediagrams.com. Again, this is one of many sites you can find. I find this one kind of nice to work with, pretty easy to get up and going. So let's start with creating some entities. All right, so what do we have in our school system? And then again, it comes down to what we want to model in our database. We don't have to cover every basis of the school. It's only what our application is going to work with. So one entity I can think of would be students. So let's create a students table in our diagram here. So we have students. Every table you create, for the most part, it's going to have an ID as a unique identifier. So we'll do that. Integer serial. think this is pseudocode, so we want that to be that. All right, so we have, this is our primary key. And just to review, we have constraints that we add on to our databases. A primary key is the unique identifier for any table. So each table in a relation database should have a primary key assigned to one column, or in rare cases, you could have a combination of columns act as your primary key. But just keep things simple here. Let's just assume that you're going to have one column that's going to be your unique identifier for your given table. And most tables will just simply have an ID column. And this is not a special reserved name. It just by default ID is like an easy field to create. But you can name this whatever you want. I'm going to keep it ID because it's simple to write and easy to understand what this field is accomplishing. And then you can add your fields. So as you're creating your tables, think about what data your application needs to store. So I'm thinking maybe first name would be something applicable for a student. Then you want to think about your appropriate data types. So again, every field you're adding, ask appropriate questions about what that field should accomplish. So I'm thinking first name, I'm thinking it's going to be a string field, also known as varchar in databases. And then let's make this reasonable, right? Most people don't have names that exceed like 32 characters. So I'm going to have 32 be my upper limit of how long a first name can be. Now, there might be exceptions to that. You might need to truncate a student's name if they have like a very, very, very long name. But I think 32 is reasonable. So that's what I'm going to settle upon. And then other questions you want to ask. Is this data optional, or is this data we absolutely want for any record we add in? So I think if we're adding a student in, they're going to always need to have a first name. I'm not going to allow a student to be entered in without a first name. So in this case, I'm going to add a not null constraint to specify that this data must exist. Looks like the docs don't like that.
So I think in this website, it's automatically not null by default, and then you have to like manually specify null if you want it nullable.
All right, thank you. Yeah, so again, we're writing pseudocode here. This is not actual SQL. So I guess we'll just adhere to that. Thank you, Andrew Simpson, for that tip. So again, I guess here we do not need to specify not null. If we're writing actual SQL, we need to specify it because I don't want first name to be optional. Same thing with last name. We'll go varchar 32. Hopefully 32 is long enough for most last names to exist out there. What else can we have? I think date of birth. So we'll do birth dates. There's a date data type in SQL. Again, we can Google all the different types. So look for Postgres database field types. So Postgres is pretty good documentation. Looks like 9.5. I don't know that's the latest, but again, there's a whole list of data types we have. We've touched on maybe like 10% of them. You can go through this list. So you've probably seen, I guess, big int. We haven't even covered that. We've seen dates. We've seen text. Again, there's a lot of them. We've not gone over most of them, but there's a lot of different ways you could store your data in your database. But we'll stick with dates. That's pretty easy to understand. And then, all right, for that, I'm going to go with that. Another entity I want would be maybe professors. So we need people teaching our courses. So we'll have professors in our system. We'll do serial PK. So PK stands for primary key here in our pseudocode. All right, so I'm assuming that professors have a first name and last name also. So we'll just kind of copy that. Let's say they have a start date. So we want to know when they started. We don't care about their birth date. We don't care how old they are, but we do care when they started. So know their seniority maybe. All right, so that's our professor table. If we want to add more, we could definitely add more fields. What else do we want to add here? We also need courses, right? That's kind of the purpose of creating a school. So we'll have a courses table. And then I want to give it an ID. And what else? We want a name for the course. That's going to be varchar 64. Maybe it's a long name. A description. Let's make that a text field, be a long description. This is where I want it to be nullable, I think. Yeah, so again, this in pseudocode, we specify if we want it to be nullable. So I'm thinking every course needs a name, but maybe not every course needs a description. That's just the decision I am making. So I just want to kind of change it up. This field will be nullable, meaning you are allowed to enter in nothing for this field, and your database table will accept it. Maybe a number of credits, like the small int.
Hey, Ankur, does the text field, the text data type, does that have a character limit?
I don't believe so. There might be some upper limit, but realistically, it might just be really, really
I
large.
think it's a memory limit. It's like a memory limit versus an actual character limit.
Yeah, I mean, you guys can do a Google. It looks like this is 65,000. I'm not sure if that's true for Postgres or all other databases. It's also a long text field. So you guys kind of can figure out if you're running into upper limits, there might be other ways to deal with it. It looks like there's a long text field, which handles 4 million characters, which should be enough for most data you're storing. All right, so we have 3 tables here. Let's think about how these might interact. So right now, these 3, students and courses, we'll talk about that in a second, but maybe courses and professors, right? In my school here, again, this is based on what your application is trying to model. I'm going to have every course can have at most 1 teacher. So it's not going to be a dual professorship. Each course is going to have at most 1 professor. But professors are allowed to teach multiple courses. So like if, let's say we have an art history teacher that's really good at singing, they might teach, 2 different courses. That's totally fine. So here we need to associate our courses table with our professor table in some manner. And this goes back to everything, every relationship we're adding, we should ask about how they're related. So as we talked about, can a professor teach more than 1 course? The answer to that is yes. So that side is many. Can 1 course have more than 1 professor? The answer to that is no. So we settle upon a one-to-many relationship, and this is where a foreign key comes into play. So a foreign key is basically linking a field from one table, usually to a field in another table, so that they will match. So that if you enter a record, it must match a value in some other table. So here I want to create a new field in my courses table, professor ID. And that's going to be an integer foreign key. I'm going to use the GUI here. So I'm going to say professor ID here, link it to my professor table. Now, again, the direction of this does matter. I notice that the many is on this side. So this is saying 1 professor can teach many different courses. The reverse is not true. So I would not want to put a course ID here and say that's a foreign key into my courses, because that would kind of flip our relationship. If I put a course ID in my professor table, that would say that each professor is limited to 1 course, but that would allow courses to have multiple professors associated with it. That's not what we want. So again, the place where you place your foreign key matters. In this case, we're placing it in the courses table because 1 professor can teach 1 or more courses in our system. Any questions about foreign keys or primary keys?
Great. I have a question about foreign keys.
Yep.
So I know in this case here that you're talking about like a one-to-many relationship where 1 professor can have multiple courses, but the course can only have 1 professor.
Yep.
But even if it is a one-to-one relationship and they're connected, isn't it still considered a foreign key since it's pointing to a different table?
Yes. So a couple notes there. Great question, Andrew. With a one-to-one relationship, which we have yet to model, we do use foreign keys for that also. But on top of foreign keys, we introduce a unique key to change that one-to-many to be a one-to-one. So we'll see that example shortly. I feel like one-to-one is a little more complicated and more rare, but good to cover here too. So yes, we do use a foreign key for both one-to-one relationships and for one-to-many relationships, but the one-to-one has an additional layer that takes away the many.
So that doesn't apply if one of the keys involved is like the primary key for the table though, because that already has the unique constraint built in.
Absolutely. Yeah. So there are a couple ways to achieve that one-to-one relationship. If you decide to use your primary key from a table as a foreign key, then you don't need to introduce a unique constraint. So we'll get to one-to-one in a second, but let's complete this example here. So again, 1 professor can teach multiple courses, but each course is going to have 1 professor. That is simply a foreign key and nothing else added. So again, the purpose for a foreign key is for data integrity. We could still model everything totally correctly if we didn't have this foreign key. But the problem is we have the risk that we can maybe create a course. So if we go back to our curriculum page, if I have that somewhere. All right, at the very bottom, I have all my seed data. So these are our professors in our system, or we're going to add these eventually. The The risk is if I add a new course, I could technically add a new professor ID, which is the last field right here, that refers to a professor that doesn't exist. Now that's going to cause a problem because students are going to show up on day one of, maybe art design 104. And if we assign a professor that doesn't exist, well, no professor is going to show up to that class. That's not what we want, right? We want to guarantee that an existing professor is assigned to a course. Without that foreign key, we risk that our data breaks that design that we want. So that's the whole purpose of a foreign key. It doesn't change the data you create, but it changes how the data is kind of validated by your database. All right, so that is why we have a foreign key, to ensure that we actually point to a real professor that exists in our system. Otherwise, this could be any professor ID, real or non-existing, and that would cause problems. Andrew Tran, question.
There's something that you said there. So when we create tables, are foreign keys like specified in the creation of the table? Is a foreign key a thing or is it a concept?
It's a thing.
Okay.
Yep.
Yeah.
Great question. Yeah, so we're going to get into writing SQL, and we'll see that we need to specify a foreign key. It's not just like some concept, that kind of just inherently gets added. We need to tell our database that we're linking two tables together via a foreign key. All right, another thing I want to create here for this example, we want to give our students lockers potentially. So if I create a lockers table, add some data here. Ivan, you have a question, comment?
Yeah, I'm kind of off track, but is there ever a situation where we're going to use information schema dot key column usage? Because I remember I was reading up on that yesterday, kind of like show what constraints each column has and like how our primary and foreign keys are used. I just wanted to know if that's something that's way beyond this course, or is it something that we might use?
Yeah, I'm gonna say that's gonna be above my head. I'm not quite sure kind of how you might use the actual constraints when you're doing queries or anything like that. Again, it might be possible, so I'll probably leave that to Google, but that's definitely outside of our scope in terms of our introduction to databases. But yeah, good that you're kind of Googling and knowing additional things you could do with these constraints. Locker number, let's have a combination. That'll be a string. Okay, so some questions you might ask, or some questions I might think someone might ask is, well, why do we have a locker number and an ID? Why can't we just use a locker number as the primary key? Now, that's a good question. There's no inherent reason why you couldn't use locker number, because locker numbers are going to be unique, right? You're not going to have two lockers in a school that have the same number. But again, IDs usually are sequential. So you're going to go ID 1, 2, 3, 4, 5. You don't generally expect or want gaps in your primary key IDs. So locker numbers, sure, they could go sequential, but if you think about schools, I think they, if you have two different floors, you might have lockers in the 100 range, and then floor 2 might have lockers in the 200 range. You might have gaps in your kind of sequence of locker numbers. So that's not generally a good choice for primary keys. Again, doesn't prevent us from using this as a primary key. So I could get rid of my ID field and use my locker number as a primary key, and nothing would go wrong. But again, in terms of design, it's better just to have a separate ID field to treat as your primary key. Now, it is extra data, yes. Again, we want to generally minimize the data we have. But in my mind, I think using locker number is not the right choice, but that can be argued. So that's not a hard and fast rule. I think it's easier to work with an ID field that's going to kind of go sequential rather than relying on locker numbers that are going to be unique, but they kind of might have gaps in them. So in this case, I went with an ID, and locker number will be a separate field in here, but that's probably going to be unique, as we talked about. You don't want to have two lockers with the same number, so you might want to add a unique constraint onto here. I don't know how to do that with this diagramming tool, so we'll do that once we get to SQL. Again, these are questions you should always ask for every field. Does combination need to be unique? Can you have two lockers that have the same locker combination? I think yes. It's probably not ideal that you have the same combination used over again, but there's nothing wrong with maybe randomly having two combinations that wind up being the same. All right, so we have our lockers. Now the question is, let's talk about lockers and students. How is that going to be related? So this is where we're going to talk about a one-to-one relationship, and this gives us some flexibility. So again, it comes back down to what you as a designer think is most appropriate. When I think about a school, I'm going to have each student's going to be given at most one locker. I've never been to a school where one student gets like more than one locker. So I'm gonna say the relationship between students and school is that one student can have at most one locker. Now let's think about the reverse. Can one locker be used by multiple students? Now, again, there's probably very different school systems out there. Sometimes locker space might be at a premium. For my school system that I'm going to model, I'm going to say, no, that's not going to make sense that one locker is going to be used by two different students. So in this case, we have a one-to-one relationship where a student's going to have at most one locker, and one locker is going to have at most one student associated with it. For one-to-one relationships, you have the flexibility of assigning the new field in either table that you want. So I could add locker ID to my student table, or I could add student ID as a field in my lockers table. So again, either or would work. So if I added student ID here, I would create a primary key. Oh, sorry, a foreign key that points to students. Right, so we have that connection. Again, the diagram's kind of hard to see, but they each have one tick mark, which establishes it's a 1 on this side and a 1 on this side, so it's a one-to-one relationship. And we'll see how to implement that with SQL. But again, the opposite is true too. There's nothing wrong with me putting locker ID here. It's just a matter of how you think the data should flow. So I'm going to actually put the locker ID up here, because I'm thinking when we get a new student, we want to assign them to a locker. We don't usually get new lockers added to our school, but we do get new students added to our school probably very often. So that's why my design decision is locker ID makes more sense to me being in the students table. In this case, we don't want to connect to ourselves. We want to connect to lockers.id. Any questions about the one-to-one here? Andrew Trent?
How come you don't link your student primary key to your locker primary key?
My student primary key
Yes,
to my
to locker primary key.
good question. So in that case, that would mean that student number 77 would have to be tied to locker number 77. So IDs, again, should be independent within between tables. So again, my students table should not care about the unique IDs for lockers. That's just an identifier internally for this table. We could, I'm not saying it's impossible. We could say that this is going to be a foreign key to the students.id table. Now we're saying any locker that exists that has like an ID has to match the student's ID. And that's going to be problematic because, again, lockers usually switch between each year. Like, each school year, a new student's going to get a new locker. That's going to kind of make our design very poor, as in very inflexible, because now we got to reassign our primary keys to match student IDs. That's not usually the way we want to go about it. So yeah, usually, again, primary keys should be left alone. They're not, almost never going to be used as foreign keys to anything else. They can be. I don't want to make an absolute statement there, but to keep our example simple, primary keys, let's just say they're going to be an ID, unique ID that has no impact outside of our table, as in they're not restricted by anything else outside of our table. Okay, so we talked about a one-to-one. When we're implementing this, again, this is going to be a foreign key, which we see right here. But additionally, we're going to have a unique key or unique constraint to limit the foreign key. So that's not a one-to-many. It's going to be a one-to-one ultimately. Okay, so we have 4 entities: students and lockers, professors, we make that plural, and courses. Now comes the hard one, and this is the one I want to maybe spend the most time on, is what is the relationship between students and courses? So if we think about it, can a student be enrolled in more than one course? I'm going to say, yeah, that's not something I'm going to prevent in our school system. So yes, one student can take one or more courses if they wish to. Now the question is for each course, can each course have one or more students enrolled in them? I'm going to say that, yeah, like we're not going to have private courses where it's one professor, one student. Each course is going to have many students in them, most likely. So the answer to that question is yes also. So we have a many on this side and a many on this side. Combining that, we have a many-to-many relationship. So again, students, one or more students can be in any course, and a A student can be enrolled in one or more courses, and a course can have one or more students. That's our many-to-many that we've identified. Sean, I think you had a hand raised.
Yeah, do you mean to have a primary key on the locker number still?
No.
Okay.
Sorry. Thank you. Sorry about that. That should not be a primary key. That should just be an int. Okay. All right, so I'll make sure we got this right. Yeah, so foreign key from my students table pointing to my locker table. All right, we good. All right, so we have a many between students and courses. And now, as we talked about before, we need a join table. And I know there's still maybe some question of why is a join table needed? I think I tried to go over it kind of rushed over it in a stand down. So let's actually try to identify why we need the join table. To do this, I'm going to go to my coding window. So let's get over here. Let's create a new file called data.sql. And I'm going to kind of pseudocode this right now. So our students table looks like it's got what? ID, first name, last name. What else do we have? We had birth dates, and we had locker ID. All right, so this is what our students table is keeping track of. And then we also had our courses is ID, name, description, credits, and professor. All right, so these are what our tables are. These are the fields we have. And I'm gonna show this in pseudocode to show why we need a join table, why it's more sensible to have a join table. So now the question is, well, one student can take many courses. How would I model that right now? Well, I could add a new field maybe to my students table and say, let's add course ID here. This would be a foreign key. So if I have some sample data records, let's say ID student 1 is going to be Anna, A, whatever her last name is, birth date, I don't really care. Say she was born 2008. Locker ID, don't really care. Course ID. All right, so we need some courses. Let's add some courses in quickly. Let's say course 1 is CS 101. Description, learn coding, credits for professor, whatever, be some random professor that exists. Let's add a couple more courses. All right, so course number 2 will be Art 102. All right, a couple more courses. Let's say we have history 202. And one more course. I don't know what courses you guys are interested in. Maybe poli-sci. Okay, so we have 4 courses. Let's say Anna wants to be enrolled in Art 102. So that course ID is 2. So the course ID I put into this record is going to be value 2. Great. Anna is now taking Art 102. But now the question is, what if Anna also wants to take History 202? With this model, how can we accomplish that? Like, we have a foreign key course ID in our students table that points to a course, but now Anna wants to take a second course. Well, this only solution we have right now with the given design is we need to add a new record in. That's going to be to Anna A. She has the same birth date, same student, right? It's just the only reason we need all this information again. What is locker ID? She has the same locker ID, but now she wants to take course number 3, right? So now she's taking Art 102 and History 202. We accomplished what Anna wanted to do, which was take 2 different courses. So again, the last item here is the ID of the course she's taking. But look at all the duplicate data that we've added in. We had to add the first name, last name, birth date, locker ID. None of these are going to be different between these 2 records. Anna does not get a new locker just because she has a new course. Her birthday is not going to change just because she has a new course. So all this stuff right here is duplicated data. And this is a very, very small scale example where we have maybe like 3 or 4 fields are duplicated. Think about, again, in the real world, Amazon, Google, they have probably database tables that have 20, 30, 40 fields in them and probably millions of records. So in this case, we have one duplication because Anna's taking 2 courses. Imagine if Anna was taking 300 courses. That's going to be 300 records with a lot of duplicate data between each of those records. So although this can work, this is not going to be a proper design because, again, we're duplicating data, and that risks us that we might get our data kind of out of sync. Like, what if we later on says, Anna, we need to relocate you to locker number 32 or 33 instead of 22. Well, we need to make sure we update every single record that Anna is referenced here. So now I need to go through my entire table. All right, well, Anna has, a second record, make sure I update that. If I forget, if I make some mistake in my querying, my updating, that's going to be out of sync. So now Anna's going to be assigned to 2 lockers, which goes against our fundamental design of lockers and students. Right, so again, this is a very small example where we have 2 records, not a lot of fields, but understand you never want to be duplicating data. You want one single record responsible for the data that you're trying to store here. So adding a foreign key here is not the best solution because that leads to duplicated data here. Any questions about that? Now, this does not prevent us from having more students that enrolled in the same course. So that achieves one side of what we want. So let's say we have Brian B has some birth dates that I don't really care about. His locker can be 44. Brian can be assigned to course 2, just like Anna is. This is not a problem. So a foreign key gives you one side of the many-to-many in terms of you have a one-to-many with this foreign key. So there's no problem with us adding multiple students to the same course. This works fine. The problem is when we want the same student enrolled into a different course. That's where a foreign key kind of does not work fully for us. As you guys can imagine, well, someone might think, well, why don't we just add student ID over here? Well, that's going to give us the opposite problem. So now if we add student ID as another field here as a foreign key that points to our students, well, if Anna wants to be enrolled into CS 101, great. We just add her ID here. So ID 1 for Anna. And then let's say Brian wants to be enrolled in poli-sci. We could add his ID here. All right, so again, kind of hard to keep track of all these IDs, but hopefully you guys are following along. But now the problem on this side is, well, what if Brian also wants to be enrolled in CS 101? Well, guess what? With our design right now, I got to create a new record and say, all right, everything else, CS 101, that's the same. The description for that course, not going to change. The professor teaching it is not going to change. The number of credits, not going to change. But the only thing different here now is we have a new student enrolled. Great. This works, but we have duplicate data. So now if, Professor 8 is no longer teaching this course, it's going to change to Professor 9. Well, I need to make sure I update this record also. I'm going to go through maybe 1,000 different records, make sure each one of those gets updated for a single change I'm making here. And as you guys can hopefully see, this is not a good design. It's not compact. It's duplicating a lot of data and makes the risk of data getting out of sync or having invalid records. So because of that, foreign keys alone cannot solve this problem. They work for one-to-many relationships, meaning if, for example, we limited our students to take at most one course, sure, we can do a foreign key on our students table, and that would prevent a student from taking more than one course at a time. And if that's what our requirements were, great. Foreign key solves a one-to-many relationship. However, we want a many-to-many because we want students to be taking more than one course if they want to, and also courses should allow more than one students. This is where the idea of a join table comes into play. Before I get into talking about join tables, any questions about the example I just kind of highlighted here? Okay, so a join table is kind of just sort of a fancy name for a new table we need to create. So that new table is going to sit between my students table and my courses table. So again, just a new table. We call it a join table because it's kind of unifying 2 tables. But otherwise, it's simply another table with some fields in it. So I'm going to call this enrollments. And now we're going to create this joined relationship. So here, I'm going to give it a unique ID. So each record still has its own unique ID. That does not change. Now we just simply add a student ID, which is going to be a foreign key to the students table. So students.id. And then we add a course ID. that's a foreign key to the courses table. That's S. All right, so we got this new table that sits between our courses and students table. So as you can kind of see, it's kind of joining them visually here. Like it's just, we have one link outside of the enrollments pointing to the students table, another link pointing to the courses table, and this central table will take care of the many-to-many relationship. Because if we kind of simulate this in our pseudocode in our window here, now we have a new table called enrollments. Again, we can name this what we think is most sensible. We have ID, students ID, and course ID. All right, so let's get rid of our duplicate data that we created. We have only one record for Anna, one record for Brian. And now we can have enrollments, as many enrollments as we need. So let's say our first enrollment is going to be for Anna. Her ID is 1. Let's say she wants to take History 202. Great, we just add in the course ID for History 202, which is 3. Maybe we want to keep track of her grade here also, so that's going to be an additional field. Let's say she got an A+ in that class. She's a smarty. All right, so that's our first enrollment. So again, the only quote unquote duplicate data are the IDs here. So I have ID 1 here, I have ID 1 here. Sure, that's sort of duplicated, but that's like the smallest unit of duplication we have. We need some way to reference Anna from this record here, and the way we do that is with her primary key. But now we could have, if Anna wants to be enrolled in another course, great. We add another enrollment. So Anna is this ID right here. Let's say she wants to take poli-sci. We put in 4 there. Let's say she does not have a grade for that class yet. So now Anna, same ID, number 1, is enrolled in multiple courses. Likewise, we can add as many enrollments as we need. Let's say enrollment 3 is going to be Brian. His ID is 2. Let's say Brian wants to be enrolled in comp sci, so that's ID 1. And let's say he's got a B- in that. And then Brian, ID 4. So his ID is number 2. If he wants to be enrolled in History 202, well, great. There's nothing stopping us from duplicating that. And let's say he's got a A- in that class. All right, so notice we can add as many combinations as we want here, and that does not impact our other 2 tables. Now, the benefit of this is, let's say, we're doing a curriculum rewrite, and we're going to decide that History 202 is actually going to be 5 credits here. Great, I need to go to one single record in one table and update that credits to 5. My enrollment table doesn't really care about that. It's just saying, all right, great, whatever data you have on History 202, if you need to use that, look in the courses table. I'm not going to manage that data here, because this table is only responsible for linking students with courses. It has nothing to do with student description, course description, any other details. Those details are made responsible by these other tables. Lyman?
So is this table, the enrollments table, is it something that really just, it's when it gets generated, it's only when you're, say, requesting data from the database and it's making those matches between the 2 tables to give you that information, or is it also storing it in that table? Or is it just simply providing a way for, like, say, if you're doing a join or you're trying to get the data that you need to see, depending on what you're doing, or is it actually all stored in that table too?
This data is stored. So these are records we're storing. We're storing simply IDs, so it's not a lot of data. It's basically like a lookup table. We're saying, all right, enrollments has student 1 and course 3. If I need more information on it, I could use this ID and then look in the courses table, because I know there's a foreign key relationship between those.
Yeah, okay, that makes sense.
Yep. So yeah, it's kind of, if you want to look at it, it's like kind of like a table of contents. If you need more information, you need to actually go to the appropriate pages, quote unquote, to learn more about the data. I saw more hands raised. Good time for questions. Andrew Tran.
Just to make sure. So right now enrollments has 1 primary key, 2 foreign keys.
Yep.
And the foreign keys, like kind of like Lyman said, like they're almost like variables that just point to like another table.
Yeah, if you kind of want to think about them, yeah, they're references. So they are referring to some other record in some other table. And then if you want to get the value of that quote unquote reference, then you got to look in that table.
And would we say the primary key here is unique also?
Yes, primary keys always have to be unique. If you have duplicate primary keys, your database table will not work. SQL will say you're trying to insert a duplicate record. So then that's your unique identifier. So again, usually we just create an ID, but for like, US citizens, you could use social security number as a primary key because those are meant to be unique. You should never have duplicate IDs or social security numbers, with the caveat, I guess, if people pass away, I think social security numbers do get recycled. That could lead into trouble. So again, that's why using just a standalone ID field is usually the best choice for your primary key. Even though, again, social security numbers should be unique, as we talked about, they can be recycled. Phone numbers can be recycled. So always just stick to creating an ID field unless you have a reason not to, which I usually do not come across. Okay, so that's our enrollment table. I think we want to add grade here. Just to, again, our join table can have extra data. Maybe there could be other designs for this, but I think simplest to create a field here. So we'll say varchar 2. Okay, so enough time on our schema design. I think we understand the links here. So we highlighted a one-to-one relationship with students and lockers. We highlighted a foreign key relationship or one-to-many relationship between courses and professors. And then we highlighted a many-to-many relationship with students and courses. It all comes down to what you're trying to model for your system. We have questions, Jesse.
Yeah, would we ever, with the join table, would we ever use a unique foreign key ever with those?
We would use a unique constraint on multiple fields. So let's actually get to our SQL. So Jesse, I'll get to that in a second. But yes, we do want a unique key here, and we'll talk about why. Yilin?
Just a basic question. Is unique key and primary key interchangeable since they're both pointing to a unique item?
Yeah, I'm so glad you asked that question. So primary keys are a special unique field that your database will use to determine different records in your database. So primary keys are essentially unique keys, but they're a little special in that they're like the main man in the operation, the primary field that's used to determine if a field is unique, like to look up a field. So each record is going to have a primary key value, and that value has to be unique, and that's how your database will look up values in your table. Unique keys are very similar to primary keys. The only difference is they're not the primary field for uniqueness. So again, one great example is, let's say we have US citizens. US citizens might have an ID field that's their primary key and a social security field that should be unique also, assuming that we don't have deceased citizens in this table. Your social security number should always be unique. That's something we want to guarantee. So you would assign an additional unique key on the social security field to say, hey, this data also needs to be unique. So yes, unique keys and primary keys are very similar. Primary keys are just that added bonus that that's the main way to identify a record in a table.
Okay, thank you.
All right, let's get to actually SQLing. So I'm going to try to create a SQL schema from this data model that I've created. So let's try to do that together here. Again, anytime you're writing fields or tables, you want to make sure you understand the relationship. So let's do create table. Students, we'll start with students. All right, what fields do we have? We have ID, serial as the primary key. Again, the serial keyword will auto-generate IDs for us. I know for a lot of our examples, we hard-coded the IDs. I actually went with a different route for our example on our curriculum page, where we're not hard-coding those IDs, because that is the more real world use case for them. Let's do first name, varchar 32. Do we want this to be nullable? Should a student be able to have no first name? I'm going to say probably not. So this is where we need to specify not null. Again, this is going from our pseudocode, which has some different behaviors than what our SQL should look like. So not null is what we need to specify. Primary keys by default have a not null constraint. So that we don't need to say not null here. It's a given that primary keys always need a value that is built into the design of a primary key. First name, last name, let's do this quickly. Copy and paste. Last name, varchar not null. I think we have birth dates as a date field. Yeah, not null. We're going to require that we enter in. Again, that's our decision. If we want to omit birth date, doesn't make that optional, we could. And then we had locker ID. All right, so we're creating locker ID here, and the order of your tables you create does matter. So here, if I want to refer to locker ID, I need to create my table first. So here I would need to create my locker ID, locker table, create table, lockers. And then let's go through this business. So each record would have a unique ID. And then each locker is also going to have a locker number. So again, if they're on floor 1, they might be like 101, 102. If they're on floor 2 of our building, it might be 201, 202. That might be our numbering scheme. So let's make this integer. Not null. I don't think a locker should be able to exist without a number. That's something I'm just going to decide. Combination. That's going to be var char around 10. Do we want combination to be null? Sure. Let's say, it's possible for some locker not to have a combination. That just means it's unlocked automatically. So that's something I'm just going to go with. So combination will be, you can have that be empty. All right. So we have our lockers. Now we could reference our locker table. So one way we could do it is add references. Which table? The table here is lockers. Which field? The primary key from my lockers table. So if you want to write a comment here, we are creating a foreign key relation to the locker table, referencing the ID. All right, so this field must match something in my lockers table with one additional caveat. Foreign keys can be nullable. Primary keys can never be null. Locker ID in this case can be null. And then this is the same question we got to ask. Can a student be in our school system without a locker assigned to them? Now, again, that's subjective. It depends what your school wants to enforce. Let's just say maybe we don't have enough lockers for enough students, so maybe freshman students won't get lockers. So in this case, I'm going to allow locker ID to be null, and that's fine. So again, foreign keys can be nullable. If you don't want them to be nullable, you have to say explicitly not null. If you want every student to be assigned a locker. In this case, I'm gonna opt for students don't need to have lockers. So I'm gonna say this is nullable. Students don't have to have lockers. All right, so we have a one-to-many relationship right now. So because we have a foreign key here, I could have two different students. I could have Anna with locker ID 73, and I could also insert Brian with locker ID 73. Nothing is stopping me with a foreign key right now to assign the same locker to two different students. So this is where a unique key also needs to be added for our one-to-one relationship. So if I add the keyword unique here, this is going to create a unique key relation in addition to a foreign key relation. So now I have that one-to-one. So this unique says no other record can match, or we can never duplicate locker ID within the same table. So the unique key acts within the table. The foreign key acts between two tables, between students and lockers in this case. Unique just says never, ever duplicate the locker ID within this table. The exception to that is you can have null records. So I could have two different students with null for locker ID. That's not going to violate my unique constraint. Unique only cares about non-null values. Sanjaya?
So right now, the student table is linked to the locker table through the locker ID foreign key, right? So if that is null, then how is that linked to the locker? I mean, if it's null, then the student is not linked to the locker ID, right?
Correct. Yeah, that's a design decision we decided, or I decided, I guess. In this case, so I'm saying every student that you create does not need to have a locker ID. So let's say, again, we don't have enough lockers for every student. So I'm going to say freshman students won't get a locker ID. In that case, their locker ID would be null, which means they're not referencing any data from the locker table. They just have no locker. So they have no locker number or combination that they care about. That record will just have null here for locker ID. And that just means they have no locker, which is fine. Again, foreign keys allow nullable fields. Lyman?
So would you say using that unique identifier is key for it making it a one-to-one relationship?
Yep. Without this unique constraint, again, Anna can have locker number 73, Bill or Brian can have locker number 73. Foreign keys do not have any uniqueness built into them. With this unique in here, if I try to insert Anna and gave her locker number 73. And then later on, I tried to add in Brian and tried to assign locker 73 here. My table would throw an error saying, hey, locker ID, you told me locker ID needs to be unique, and now you're trying to violate it. Sanjaya? Oh, that might be a hand raised from previously. Yep. All right, Kat.
Yeah, so like with the current model, if there was like a new school year and you wanted to reassign lockers, you would like wipe all the data in order to be able to, and then like input it again. Is that right?
Yeah, you write a query that says set locker. Let's do a quick query just to take a quick tangent. I do select star from students. I would say, or sorry, I need to update. So I need to do update students, set locker ID. I'd wipe them out to null. So every student will be reset to null. And then later on, I have a new script saying update students. And then I need to go one by one and say set locker ID for, say, locker ID 77, where student ID equals 1. So yeah, you need to wipe your data and then reassign them this way. There's no, or you could drop your constraint and kind of do that and then re-add your constraint. So that's another solution if you don't want to set them all to null, but probably better to wipe them out and then reset them. Okay, I think we're probably due for a break here. So after the break, we'll complete our schema. So again, we've done one part of it. We created students and lockers and established this one-to-one connection. We'll finish this up and then we'll go on from there. Okay, let's take a break. It is 10:53. Let's take a 12-minute break. Please be back at 11:05 and we'll continue on here. All right, so we're working on our schema right now. We created our students table, our lockers table. We linked them with a foreign key and a unique key between them. The reason we want a foreign key and a unique key is to guarantee that we have a one-to-one relationship, meaning we don't want the same locker ID used for different records in our student table. So we achieved that by adding the unique key right here and references right here. Again, the syntax for adding unique keys and foreign keys, there's a few ways to do it. You can see it this way. You could also do it with an alter table statement. That's usually the way I prefer it. So usually I create all my entities and create my relationships after that. But this is kind of quicker to write all in one line. So that's one up there. Got my semicolons as I see. All right, let's continue on. So we want to create another table. Let's go with professors. If there's any questions, again, anytime, please stop me. This review is meant to be beneficial and informative. So professors, we had first name, last name, and ID. So I'm going to copy that over. I think we had start dates as a field. That's probably not null because they all started at some point. All right, so that's my professors table. I don't think I need anything extra there. Just gonna kind of zoom over that unless there's any questions about that table. Let's create our courses table. All right, so courses is gonna have a primary key. I'll leave that intact. They probably have a name, varchar 64, I think is what I stumbled upon. I'm gonna make that not null, as in every course needs a name, but I'm gonna say description is gonna be optional. Sometimes the course name will be enough for us. So let's make that a text field. This will be a long description, but I'm going to allow it to be nullable. So I'm not going to write not null here. What else? We have credits. Credits is required. Each course must have a set number of credits. So let's go with small int and say that's not null. And then as we talked about, a course is going to be taught by a professor. So the question becomes, where do we add that foreign key? Do we add the foreign key to our professor table and say course ID? Or do we add the professor ID here? Again, it takes a little bit of thought. So again, this is where the designing portion comes in. If we added a course ID to the professor's table, that's going to tell us that each professor is limited to one course. And that is not what we want. So again, the foreign key should go on the many side, meaning a professor can teach one or more courses. Therefore, the professor ID should be the field you add to the courses table, and that is going to be your foreign key relationship. So references my professor's table. Oh, we need to type here, integer. References professor's table, and the field it's referencing is the primary key or the ID field. Again, same question we should ask for every single field we add. Should this be unique? So let me ask a friend in the audience. Let's go with Aiden. Aiden, do you think this field should be unique, set to unique here, or should that be non-unique?
Non-unique because it's a one-to-many relationship.
Correct. Yeah. So if we made this unique, that would limit us to having one professor teach only one course. But Aiden's correct. We want to have a many on the side. So non-unique, as in we just omit the unique keyword. Should this be nullable? Edgar, do you think this should be a nullable field or non-null field?
So it looks like that is the foreign key, so it is allowed to be nullable.
But should we have it nullable is the question.
Oh, no.
So it should not be null. I would agree, because each course
Yeah,
should have
should
a
not.
professor set to it. Again, this is a design decision. So any course that we have in our system should have a professor assigned. That is what we are signifying by this not null. So this is, we are creating a foreign key to the professor's table.
But just to clarify, you did say that if it's a foreign key, it is allowed to be nullable.
Correct. So foreign keys are nullable. So if we omit the not null here, this is saying that we can have a course in our table that has no professor associated with it. Again, that's up to if we want to. That is different than primary keys. Primary keys by default cannot be nullable. So in this case, we don't need to specify not null for primary keys, but for foreign keys, we do need to think about it. In this case, we do want professors, each course to have a professor definitely assigned to it.
And another question, because it's professor ID, does it always have, can that just be like could you set a word or like, yeah, like a series of letters as an ID instead of using numbers?
Yeah, again, yeah, your primary key can be anything unique that you want. So I think Raphael talked about using UUIDs yesterday, which are more unique and universal. So yeah, you do not have to reference ID. ID does not need to be a primary key. We just do that as, I guess, just customary to have an ID field, but I can reference anything else. You do not have to reference the primary key in another table. This is something maybe we want to emphasize here. So in each case right now, we're referencing the primary key. That is not required for a foreign key. A foreign key can reference any other key that exists. So you can reference another unique key, you can reference another foreign key, you can reference a primary key. That's what a foreign key can refer to. So I guess we don't have a good example here, but here, let's say I want to make locker ID be locker number. In this case, I could say this references lockers and then locker number. Let's call this locker no. This is totally valid. We have a field that is referencing the locker number field within my table here. But I guess one thing I'm missing here is that locker number here is not guaranteed to be unique. Right now, locker number can be duplicated in my lockers table. So I probably should add in unique here so that we don't have two individual lockers that have the same locker number. So again, a foreign key here can reference some other field that is not the primary key. So this is a valid design also if you want to store locker number instead of locker ID. In fact, this might be more appropriate because when you hand out information to students, you tell them what their locker number is. You don't tell them like the ID of the locker in your system. If that makes sense. So I'm going to leave this change. I know that's a little different than what we have on the curriculum page, but just to highlight, you do not have to reference the primary key in another table. It could be any other field that you want that is has a key on it. So we're referencing the locker number field.
But if you don't reference a primary key, do you need to specify unique?
On this side, no.
Okay.
But so again, unique is used internally. So the question is, should locker number be unique in here? If I left this out, this would not be correct because yes, although each locker number within my lockers table is guaranteed to be unique, there's nothing stating that each student is going to get a unique locker number. So again, Anna and Brian might get locker number, 201, because I've not told this table that locker number needs to be unique, even though each locker that does exist will have a unique locker number. Does that make sense?
And does leaving it like this, does this change the relationship from like a one-to-one to like a one-to-many?
Yep, exactly. Yeah, because now this allows one locker to be assigned to multiple students. So yes, in
So
this
now
case,
it's a one-to-many.
yep, it is a one-to-many because we took away this unique constraint.
And then once you had unique, you go back to a one-to-one.
Yep, it's one-to-one because this keyword says, hey, whatever value I assign in locker number, that should never, ever be duplicated across other records in this table. So again, unique acts internally, foreign keys kind of point externally to some other field. Good questions. All right, so we have our courses table. Again, the foreign key we added here is a not null foreign key that points to a valid record in our professors table. Okay, any questions about courses and professors? Again, that's our one-to-many. So let's say one-to-many, use a foreign key. This is a 1-to-1. Use a foreign key plus a unique key. And this is nullable, meaning a student may not have a locker. Versus here, this is not nullable. Not nullable. A course must have a professor. Jesse?
Yeah, is this the integer unique references, is this unique just for that row or for the entire table?
Entire table. So unique says whatever field you have should never ever be duplicated across every single record. So if I have 1 million records, each one of those records should have a unique locker number. They should never match any other record in that table.
Okay.
But again, it's always internal. So this unique has no impact on any other fields in any other table. All right, so we have courses and professors. Our last table that we need to create, if we looked at our schema, so we did students, we did lockers, we did courses, we did professors, our join table. Again, we need this to model our many-to-many. Otherwise, we're going to wind up with duplicate data. We're going to have a poor database design if we do not have this join table that we create. So again, this is just like any other table. We create a new table and we name it. So in this case, we chose the name enrollments. And then we want to give it a unique ID, just like any other table. And now we're going to create a few other fields. So we're going to have student ID to pair the student, to link in the student table here. So it's going to be integer, not null, because each enrollment, we don't want to have an enrollment that has a student ID that just doesn't exist or is empty. So not null, references, what do we want to reference? The students table and the ID field in there. And likewise, we want the course, oops, I need a comma there. Course ID, integer, not null. References, courses, ID, and then we want a grade, I think. So student may have a grade, they may not. So this is going to be a nullable field. Because if they're still going through that course, they probably don't have a grade right now. So this will just be bar chart 2. All right, so this is a one-to-many for students. This is our one-to-many for courses. And then together, this is our many-to-many. Okay, so that is our 5th and final table for this example. Any questions on what we have here? Jesse.
Yes, going to the bottom of the table. So we do not want to put unique on those because of the many-to-many relationships.
Yes, so I like the question you asked because there was one thing that I wanted to add here. Jesse is correct. We do not want to make these values unique. If I did this, oops, if I could actually type correctly, that'd be helpful. if I added a unique constraint to student ID, this is going to be back to our kind of original problem where this is going to limit a student to be enrolled in only one course. We can never see the student ID in this table again if we added unique here. And the same would go for course ID. If we added unique to course ID, that course could never have more than one student enrolled with it. However, there's an interesting question brought up here. Let's say we have Anna who has student ID 1, and she's going to be enrolled in class number 3, which was, I don't know, art history or whatever course it was. Is there any problem with my current enrollments table? Is there anything preventing Anna from being enrolled in art history 3 different times for the same course? Like, can I have 3 different records with Anna's student ID and the same course ID? Is there anything preventing that? And is that something we want in our design?
It looks like that it just will duplicate records.
Right, and it wouldn't really make sense, right? A student, if they're enrolled in one course, it wouldn't really make conceptual sense for a student to have 3 enrollments in the same course. Like, why would they have 3 desks and 3 grades or whatever else? No, so one student should be paired with one course, and that should never be duplicated. So this is where a unique key can also help us. So instead of assigning unique to this field and a unique to this field kind of separately, because that is not what we want, right? We want multiple student ID, or the same student ID to be in this table multiple times. But we do want a pairing to be unique. And that's where I'm going to add unique here and say student ID and course ID together should be unique. So this is saying no student should be enrolled in the same course. No same student should be enrolled in the same course more than once. So this pair in tandem should be unique. And this is totally valid for setting a unique key. So again, unique keys, primary keys, foreign keys, they can be applied to multiple columns in conjunction. They don't always have to be a single column. Usually they will be, like professor ID, that's just a single column we're applying a foreign key to. But again, you can combine multiple keys together or multiple columns together to create a single key. So now we're preventing adding Anna to the same course multiple times because that would not make sense for our needs. We want to have one enrollment per combination of student and course ID. So that is a constraint we do want. Again, these are decisions we need to think about. Again, a lot of decisions we're making, but that is the job of being a database admin or database developer. Want to make sure you answer all the questions up front in your schema and don't leave that to like chance, or don't leave it empty and say, that's fine. Whoever's inserting data won't make a mistake. No, you should catch mistakes with your schema design. Yelan?
Thank you. So is that the required like way to write unique with the 2 other elements, or you can't put multiple elements within that parentheses? Like say you want the grade to become another unique key as well.
So could you explain that example? So if you want grade to be unique, what does that mean? Do you want like if we're grading on a curve and you don't want to assign the same grade to 2 different students in the same course?
It's more like a student won't have 2 grades for the same course.
Well, yes. Well, this prevents it. So this is saying no student in course combination can be duplicated. And by default, that means grade can never be duplicated because there's going to be one record for Anna in art history. So therefore, she's going to have only one grade ever existing in the enrollment table for that course that she's in.
Makes sense. Thank you.
Yep. Andrew Tran.
So if you wanted to make only student ID unique, you could put unique on line 37, or you can just write unique on line 40 and you take out the course ID like that.
Yep.
Okay.
Multiple ways to write the same thing. Again, alter tables. You can also add unique constraints with the alter table command. That's something I do want to show, but not as important. But you guys can look up, again, I'm just doing Google for you. You guys can do the same Google. Alter table, add unique constraints, Postgres. All right, tech on the net. Let's see if they have a good example. So they added unique here. I think this is extra, as in unique alone can do it in Postgres. But if you want to do it after the fact, like after you create your tables, you'd have an alter table statement add constraint, name your constraint, and then the type of constraint. So it's a little more writing. I prefer it this way, to be honest. I prefer creating my tables and relationships afterwards. The reason I'm doing this way, A, it's easy to kind of see it all in one line. But yeah, it's not wrong either way. I just have my preferences. I think creating tables and then create all the relationships afterwards, rather than kind of, creating this field and I realize, oh no, I need to reference some other table. So let me create that table now. I'd rather just do all the tables first and then the relationships after. Okay, so those are our tables. I think we have all of our constraints set up. So again, a lot of decisions we had to make with our constraints, like not null, foreign keys, unique keys. I probably want to add course ID back here. Jesse.
Yeah, with your comment that you just said about having the alter table at the very end, so you can have any of these create tables in any order you wish, and then just do the alter table, and you don't have to worry about that.
Yep, that's another benefit of using alter tables. So currently the way I have it, I need to create my lockers table before I create my students table, because my students table is referring to my lockers table. If I swap the order of this, I would actually get an error. So I move this up here, as Jesse said correctly, this will be an error because right now my definition has a relationship built into it. But if I decided to create my tables first and then my relationships, the ordering of my tables do not matter. And that's one reason also why I prefer doing alter table. So I don't have to worry about, the ordering as much. So again, if I did it that way, I'll just do alter table, add alter table students, add constraints. I always have trouble spelling all these words. Constraints. And I'm going to name this constraint. So if I was adding a foreign key, I would say student lockers is what I'm going to name that constraint. Foreign key. And then I want to tell it which table, lockers, and ID. And then I think that should be it. So add alter table, add constraints, foreign key. I think that's correct syntax. And, so yeah, this is the same thing as this, except I don't have the unique constraint in there. So if I wanted the unique constraint, I would need to add that additionally. So alter table, students. If I don't want students to have the same locker, I'll need to add constraints, unique, what field? Locker number in this case. I can call that locker no. So this is a foreign key I'm adding for the one-to-many, but I want to restrict that to be one-to-one. So this unique key is needed. So both of these in tandem create my one-to-one relationship. That's the same thing I'm doing all in one line right here. So again, I would argue this is way easier to write, but I like being explicit about it this way. Your choice though. Okay, I do want to give you guys some time to code. So let's run the schema. Let's make sure that I don't have any errors in it. Quite possible I do, because SQL is not the easiest, right? But I'm going to create the database. Let's call it create Friday school. Say it's Friday. Create DB, of course. All right, so I'm going to create a database called Friday school. All right, no error messages means that was valid. So I'm going to do pSQL. pSQL, the name of my database, so Friday school. Feed it my schema file. So hopefully I don't have any errors here. Semicolons are there. Oh, I have extra commas. That's something that's going to cause some headaches. So make sure you don't have extra trailing commas. SQL does not like that. Okay, I think this is correct. Fingers crossed that I don't have any stupid errors. All right, cool. No errors. 5 tables got created. Thumbs up. Our schema seemed to work. But now let's actually test it with our data. And for this, I'm going to get rid of this garbage data or pseudocoded data. I'm going to go to our curriculum page and copy my seed data file. So I have some data here that I'm not going to type out myself. I will need to change one thing because I took a deviation from what the curriculum page has. Instead of using locker ID, I'm using locker number. So I need to match locker number, not the ID. In fact, let's get rid of the ID. As I said I would. I don't want IDs here, so let's go away. So this is a question, I believe Phil asked this in a breakout room, and I think it's a really good question. So again, a lot of our examples have hard coded the ID. So again, I had ID specified here, and I'm explicitly setting the ID here, but we have set up the ID to be a serial field, meaning if I omit the ID here, that's going to be automatically handled by the serial field business behind the scenes. So this is normally how you would be inserting values. You're not telling the system what the ID should be. The system is going to tell you what the ID will be once you insert a record. So here I'm not specifying IDs for my students, professors, or courses, but the caveat there is I'm going to assume that they're going to take on the appropriate IDs that I'm referencing here. Shun, you have a question?
Yo, if you do hard code that ID in, it's the hard coded ID. That's what it's going to take, right?
Yeah, yeah. That's going to screw up your sequencing. So if you remember from SQL Basics, I think you had to kind of mess with the sequence table if you do it hard coded. If you hard code the ID, looks like I have a typo here, not Bill or Bill. All right. All right. So I'm going to try running this. I need to update my locker ID. So notice this is going to be locker number. And then I need to match some of these locker numbers. So let's say Anna gets locker 102. Let's say, I'll make sure my data type's correct. So I said locker is an integer. That makes sense. Okay, so Anna gets 102. Let's say Bill gets 104. Cassie will get 205. And David will get 207, whatever. All right. So I've updated my data since I decided to use locker number and a foreign key to the locker number field. I think this was locker number. So I want to make sure my field names are correct. So yep, locker number and combination, locker number and combination. I think these are right. All right, I'm going to run this. Hopefully I didn't change too much between the curriculum page and what I have here. Start date, description, credits. All right, I think this should be correct. Let's try running our data file. So we have our tables created. Let's run our data files. So I want to run pSQL, Friday database, Friday school, and then I want to insert or run data.sql. All right, hopefully my data is kosher. All right, I did get an error. This is where we talk about we don't want these errors, but it's okay if we get an error. Let's try to figure it out. So looks like the first three inserts worked. So 8, 4, and 5. So that's 8 lockers, 4 students, and looks like 5 professors. So it looks like, again, insert professor ID, enrollments violates foreign key constraints, course ID. So it looks like course ID 2 is not present in our database. I'm not sure why that would be. Let's actually investigate our tables. So I'm going to go into pSQL. I'm going to do, oops, quit out of pSQL. Let's go to pSQL Friday database. Let's check out our data here. Friday school. All right, I'm going to do a select star from professors. Yeah, professors. Okay, so we have 5 professors. We definitely have a professor with ID 2. I'm not sure why this was complaining. So let's read the error message again. Insert update table enrollments violates foreign key constraint enrollments course ID. Course ID. So I need to search courses, not professors. Courses. All right, so it looks like courses did not get added in here. Did I not have that in my data? Okay, that is my mistake. So actually, no, I have courses here. I'm struggling to know why this didn't get added. Anyone see any mistake I made? Let's see. So we inserted 8 lockers, 4 students, 5 professors, but then it.
Is the course ID the name or is it?
Oh, sorry, I'm looking at 2 different errors. So professor ID. I bet I have the wrong column name. So, oh, I said professors with an S, so we could change our data. Typos, again, hard to deal with. Sorry. So that was the error here. I was referencing the wrong field. And then I think because the courses failed, we didn't get our enrollment. So I'm gonna, sorry for the mistake there. All right, so the mistake was I was inserting professor ID instead of professors with an S, because that's what I accidentally named it here. We could do an alter table statement to update the column name here. If you guys are interested, we could do that. But easier fix is, all right, I'll just match the field name I have here. My courses did not get entered, and therefore, when I tried to add my enrollments, it was complaining that course number 2 doesn't exist because that didn't get inserted. So I'm going to run my data file for my courses and enrollments. All right, cool. So we got 6 courses we have to choose from: CS 101, CS 202, databases 203, cooking 301, singing 203, and singing 307. And then we have 10 enrollments that we have created. All right, so that's our data there. Now I'm going to give you guys a challenge. I don't know if you guys have been following along. You guys should be able to use the curriculum page to achieve what we have created here. Again, I did make a change where I used locker number instead of locker ID. Hopefully you guys can navigate it. Regardless of if you have the data working or not, you should be able to write a query. And this is the challenge I'm going to give you guys since we have a little bit of time. I'm going to create a queries.sql file. And first question I'm going to ask you guys is display the course names for the students that has a locker with combination deal with 17, 27, 37. All right, so I'm going to ask you guys to solve this using the information provided. So to be clear, I am telling you what the combination of the locker is we're targeting. You need to display the course names, and let's say student names also. Student name. You could do first name and last name, or just first name, it doesn't matter. So I want you to show the student name and the course name or names for the student that has a locker combination of 1727. What I don't want you guys to do is say, all right, I'm a human, I'm smart. I'm gonna look at my data and say, all right, well, I know that the combination 17, 27, 37 is for locker 207. I know that locker 207 belongs to students, whoever that student was, belongs to David. So I can kind of take David's ID and kind of short circuit what my query should be. No, you need to use the information provided in the requirements. So you're gonna need to start with the provided combination and figure out how to get to course names. So don't do it manually in your head. Write a query that's going to accomplish exact requirements. So given a combination, show me the student name and course names that you have here. So now I know you may not have the data here, but you still should be able to write the query. You might not be able to test it, but you should be able to write the query here. So it's 11:36. Let's say take 9 minutes on it. I don't know if that's enough time or too much time, but let's say take 9 minutes, write a query. I'm going to put up my schema design in case you want to try to follow the flow. So think about where you're starting. We're starting with combination. And you need to get to maybe student name and also course name. So think about maybe some joins you'll need to do. Hint, hint, you will need to do some joins in your queries. But we have combination. We want to get student name and course name for that student. So I'll leave this up here. I'll try to get this question somewhere listed there too. But take some time for it and good luck. I don't know where I have to write this question. Let's write it down here. Sorry, I'll write it in my address bar, that's fine. So that's your question right here. Display the student name and course name or names for the student that has a locker with combination 17, 27, 37. All right, so take 8 minutes. We'll regather at 11:45 and we'll answer this together. And just to kind of highlight this will probably be similar to the hardest query we're going to ask you to write on assessment 3. So that's why it's good practice here.
Hey, Uncle, are you there? Can you put the question on the page or in the share?
Sorry, Lyman, I stepped away. What was that question?
Yeah, can you put the query, what you're trying to get us to query on screen?
Sorry, I'm having trouble picking up your audio.
Can you hear me now?
It's
can
in the
hear you. It's a
browser,
bit-
Lyman.
Say again?
It's in the search bar of the browser.
Okay, got it. Thank you.
All right, let's take a couple more minutes if you're still working on it. We'll go over it together, and then we'll get you to assessment 3 afterwards. So if you are struggling or still working through it, take it piece by piece. So usually I try to go from one table to another, and then figure out how to get the data kind of synced between 2 tables or listed between 2 tables, and then move on to the 3rd table. So don't try, I would say if you're again struggling, don't try to do all in one swoop. Try to just get the data from one table, then the data with 2 tables combined, and then keep going to other tables iteratively instead of doing it all once if you're trying to get there. All right, maybe one more minute here. Do your best to write the query. Again, if you don't have the data, I know it makes it a little harder to test, but hopefully you kind of understand what the query should look like, and if you can't, test it right now. Okay, I'm gonna call time there. Hopefully that was enough time to get started, have a rough idea, and if you didn't get your query fully finished, but I do wanna have enough time to go over it together. All right, let's try to do this. So I'm gonna go back to my coding window. Again, it's nice to have the diagram. I can't really do a split screen effectively right now, but hopefully you kind of have a good idea. I might gonna flip back and forth if that's not too disorienting. But again, key advice here, as I mentioned, try to take it piece by piece. So I'm going to start with the information that I have, and then eventually get to the information that I want. So the very first thing, I'm just going to write a simple query to select everything from my lockers table where combination is equal to 17, 27, 37. So again, I'm not solving this problem entirely right now. My only goal right now is to make sure I can list all the details for a particular locker, since that's the starting information I have. So if I run this quickly, I'll just do pSQL Friday school, forgetting the name of my database, and run my queries file. All right, so notice I get 1 row back because there's exactly 1 locker that has that combination, right? We insert the data, hopefully remember our seed data up here. Let's uncomment that, but yeah, we only had 1 locker that has that combination, so I would expect 1 row to be returned from that query. All right, so that was step 1, just getting the data from the lockers table, because that's where we are starting off with the combination that we are given. All right, so now let's move on. So we have all the data from here. We want to incorporate our students' data in here. This is where we need to use a join. So usually you're going to do a join on foreign key relationships. So these wires are how your join will effectively work. So since I have a foreign key from locker ID and students matching the primary key in lockers, that is what my join is going to be on to kind of link this table in with my query. So if I go here, I'm going to extend my query and say, all right, I want to join and bring in my students table because I have data in there that I care about. And I'm going to have to tell my query, how do I match up records from my students table with my records in my lockers table? Again, we need to know how this is done. I actually need to change this for my example. Sorry if this is going to be a little confusing, but I changed this to locker number. And that's actually pointing to the locker number field. So I'm not looking at the primary key. Again, this is totally valid. You could have a foreign key from a field to a non-primary key. In this case, I have locker no here, and students table pointing to this unique field locker number. So I made a unique constraint for that. All right, so given that this is my design, how do I link these together? Well, student.locker number should match the locker number in my lockers table. So that my on statement is going to say, let me add in some aliases here. So S is going to refer to my students table. So S.locker number, that's the field in the students table, must match locker.locker number. this is how the join is going to unite records. So now if I run this query, instead of just getting my locker information, I should get the student information for the student that has this locker number assigned to him or her. So if I run my SQL query again, notice what my output looks like now. So my join, basically, if I could highlight it, these fields are coming from the student table. The ID for David is ID 4, first name David, last name Derby, birth date, whatever that birth date is, and locker number is 207. Notice that this locker no matches this locker number, because that is exactly what my join was done on. I said that both of those fields need a match for this join to kind of give me results. All right, so that's step 2. We've incorporated our student table. If you remember our original objective, we want to display the student name here as part of our output. So I already have access now to first name and last name because I've linked in my student table. So I could change my select to say, we don't want everything. We just want student with s dot first name and s dot last name. All right, that's the student name. So if I run this query one more time, well, great. This is the only information I want. So again, we don't always want to do select star because that's going to be extra information. If our query didn't request it, we should not be doing select star. Just get everything back. So in this case, we want student name. So I've provided first name and last name. So that's halfway there. But we also additionally want course names here. So this is where we just keep going through our diagram. So we've linked with one single join, we've linked lockers and students together because we match locker number or locker no with locker number between two tables. But our challenge is asking for, we want course names also. Course names is all the way over here. We don't have access to course names right now, right? We have these two tied together with our query. How do we get over the courses? Well, there's no link directly from students to courses nor lockers to courses. So we need to go from one table to another and kind of step each way. So we don't have connection to courses directly, but we do have a path to courses through enrollments. So I need to add another join that combines students with enrollments here. And again, just find the matching link here. Student ID from enrollments matches the primary key in my students table. So I'm going to add yet another join. Here, I'm going to say I want to bring in enrollments. And how do I want to link that? Now, again, lockers does not have any direct link to enrollment. So my on statement is not going to incorporate lockers. It's going to incorporate students and enrollments because those are that's where the link exists. So I'm going to say enrollments E. I'll say E dot student ID must match student dot ID on this join. All right, so now I'm bringing in enrollment data. And if I want to see what this looks like, let's add in E dot star for now. And I'm going to run my query. All right, so notice what I get here. I got first name and last name because I've said that's exactly what I want. I did E dot star. Again, E refers to the enrollment table. So everything from the enrollment table is listed right now. I have the ID of the enrollment. So it looks like I've done this twice. Right. I'm going to ignore the ID here. I'm not sure why that's kind of off from what I expect, but student ID is 4. That is David's student ID. Course ID is 1, 2, and 4, and he has a grade F, null, and B minus. So again, our ultimate goal was course names. We don't want just course IDs. We don't have access to course names through enrollments. Enrollments does not care about course details. All it's telling us is which course we have. If we want information on that course, well, guess what? We need to do yet another join. So we had one join that links students and lockers. Our second join links students and enrollments. Guess what? We need another join to get to the courses table here. So we're going to match course ID with the primary key in courses. So if I write yet another join here, just going to another table. Now we have courses part of the party. I'm going to join it on C.ID must match E.course ID. Again, I want to emphasize the ordering of this comparison does not matter. You could swap CID and eCourse ID. That's fine. But here I'm saying the primary key of the course table must match the course ID for that given enrollment record. So now if I run this, let's show C star also. C dot star. Oops, courses, plural. Sorry about that. All right, there we go. Notice we got this really long record because we're basically merging table records together with these joins. Now we have first name, last name, cool. These items are from enrollment table. all of these items are from our courses table. So now notice that we have access to name through this entire query, right? We joined a bunch of tables together. We eventually got course name involved when we started with just combination of the locker. So we hopped from one table to another, get to another table, get to another table. And that's what join is doing. It's just saying, hey, lockers, I don't have enough data that I need to bring in another table. That's what join's saying. Join's saying, give me data from another table included. All right, so now we have all this information, but we don't want to show, we don't care about their grade. We don't care about the course ID because our query request was just student name and course names. So here I could do c.name, and let's give this a run. Okay, so now given my combination ID, I am able to show the student name and the course that this particular student's enrolled in. So it looks like that whoever has locker ID locker combination 172737 is in CS 101, CS 202, and cooking 301. Any questions on that? How did you guys deal with the challenge? Did it make sense? Did the walkthrough make sense? I want to make sure we're good in a good place here before we wrap up our review. So open it up to questions. I see a thumbs up from Jesse. That's positive to see. Any other thoughts?
I think it was just good to watch how you go through and create the statements. You start with the where and you start with the final thing that you're using to filter through, and then you work your way up.
Yep. Again, yeah, I would highly recommend just do it piece by piece. Don't try to write 3 joins all in one because it's easy to get confused, especially for me. So again, I will start with one table, get the data I need. If I don't have enough data, then I'll say which table has the data I need. So let's say, for example, we need to get the professors. Like, what if I change my query to say, give me the professor name for the courses that the student, it's going to be kind of poor English here, who has a locker with combination. So now I'm asking for professor name for the courses that the student has. Okay, hopefully you guys can parse that. Well, now I need to get to this table. So that's just another join we need to do. Follow the links. All right, we got to courses, but now we need professors. So I'm going to change my query a little bit, say join professors. Very join happy query here, but this is totally a valid query. We'll say p dot ID must match the course that they're teaching. So professor, I think I had S for naming there. So the professor ID from the course must match the primary key on professors. And then here, I just want to show the professor name. So I can just do p dot first name, p dot last name. Now we're getting a list of every professor that teaches a course that has a student who has a locker that has a combination of 1727. Again, a lot, kind of hard to say in English, but with our query, great. We know that Charlie Chaplin, Vince Vaughn, and Rachel Ray are professors who teach a course that has a student who has a locker whose combination is 172737. Okay, I saw a hand raised, I think. Jake.
Yeah, I'm just wondering, doesn't line 5 and 6 there sort of create, I want to say, like an invisible table of students and lockers combined that can then be combined with enrollments?
Yep.
On the student ID, because enrollments that join would have access to all of that, or does that order matter? Do you have to do from lockers first because it's not connected to enrollments in any way?
We could actually do this. We could actually flip this order. So joins don't always really care. So I could actually do a join on lockers. So let's do it this way, just to see how this works. So I'm going to say the join here. So I'm going to start with my students table. That's fine. It doesn't really matter where you start. I just start on lockers because that's where I have my data. I could say select star from students, and then we just swap the way the join is going. So we're joining in lockers now. We match locker number with locker number. Should be the same result. Yeah. So again, the order of your joins doesn't really matter. I just do it in kind of how I do it mentally. Start with my table that I have the data in, and hop to the tables kind of in order with my joins. But yeah, these joins I can flip. I can make this. This lets me. I could add professors as my first join. It's not going to matter. It's a little harder to parse because obviously I'm referencing something called C here. I don't know. Actually, I'm curious if this will work. Yeah, sorry, this will not work. Sorry, because I defined this variable down here. I wonder if I took away these. Sorry, I'm getting kind of off track here, so maybe I should abort this, but I'm gonna tinker with it while Andrew Tran asks this question.
So select statements are pretty much like the gist of them is like they're the same no matter what. They're selecting something from some table. It can be small or it can be like super huge, like this table. And then you can add a where clause, right? Down at its core.
Yeah, the where acts on the combined table here. Just to amend what I was saying before, you can't reference a table that you've not brought into the party. So here I'm trying to do bring in professors by linking in courses, but since I'm defining courses later on, I guess the joins do matter in that case. So I can't do courses that professor's ID. Looks like I'm getting error because it's saying it has no idea what courses is at this point. Trying to make sure I haven't made a mistake here. So courses. Yeah, so I think the order does matter in terms of how you reference tables. So let me just change that back. Yulin?
Thank you. I just want to make sure, is the reason you would be able using the alias in your select statement before like visually others declared, is it because select statement is executed in the end, like the very last one?
Sorry, I didn't quite catch the
Like, because visually the alias, the p dot first name, like it's before when you actually create the alias, because it's on line 9.
Yeah, I see. Yeah. So yeah, these aren't, I guess SQL queries are kind of hard to kind of understand how they parse. First thing is we create the table. So this highlight part is a table we are creating to search. And then we have a where clause, and then select actually happens last. So if you were trying to see the order, it's actually like this, where we create our table and then we kind of filter it, and then the select is the last thing that happens. So this is actually like the order it goes in, but usually you see select as the first line of the select statement.
Thank you.
Yeah, SQL is a little weird like that. Any last questions before we get to assessment 3? Okay, so again, take your time with designing your schema, understand the relationships, make sure you have the proper relationships and constraints. As you're doing queries, make sure you kind of understand the visual flow of connecting tables with joins. All right, I'm going to stop the recording here.